All right, we're doing 2.6 day 2. The strategies we'll be following today are the same 5 strategies as Friday. So if you took a picture of this Friday or wrote this down Friday, nothing to write down again. We're going to be making our P and Q list. We'll be graphing it in the calculator to maybe narrow down what we think the solutions are. But then we'll be verifying those solutions using synthetic division and factoring until we find all the solutions. Okay. So, let's look at our first example. It's a cubic, so do you know how many solutions there'll be? 3. So we're going to start making our P and Q list. Who would like to tell me what will be on my P list? Chris? Here's a hint. Yes, 9 will be on the list. There's more.
1.
Yep. Anything else?
3.
Yes. And I'm just going to write 3 once. So 1 times 9 equals 9. 3 times 3 equals 9. That's a complete list. All right? Who wants to try to make a Q list? And this is where this lesson becomes different than Friday. Friday, our Qs were always 1s. Today, they're going to be more Qs. Megan? 1, 2. Yep. All right, we get to make our list of all positive or negative P over Q values. Could be not super long, but medium length. 1 over 1, positive or negative 1 over 2. 1 over 1, 1 over 2. 3 over 1, 3 over 2. You do have to put the positive or negative in front of every one. I'm sorry. I know it's a pain. Positive or negative 9 over 1. Positive or negative 9 over 2. Okay. So all those guys are not going to be solutions. But if there are rational solutions, they will be included on our list. All right? What do we do now? Do you remember from Friday? Yeah?
Plug it into your calculator and find the x-intercepts.
Yeah, let's graph it and see if we can find any x-intercepts. Even if we can only find one, that'll be enough to get us rolling into our synthetic division process. I'm going to shrink this a little bit so I have room for my calculator. So we're looking for x-intercepts because x-intercepts are the same thing as zeros. They're the same thing as solutions. They're our ultimate goal here. So just a reminder about x-intercepts. Ooh, did I graph this wrong? Yep, I forgot my squared. Make sure you've got 7x squared or you're going to be getting the wrong answer. Look at me. It didn't go in where I wanted it. You found them already? Oh my gosh, I'm having some troubles. Let me just type it in over here. This is easier. 2x to the third 2x to the third minus 7x squared plus 9. This should look better. All right, so just a reminder to our friends on YouTube, if you're looking for x-intercepts, you're looking for y values of 0, and there should be 3. Now, maybe not all of them are at nice, happy integer locations, but I think 2 of them are. Where's this one and where's this one? -1, +3. And a good place you can go to look for these if you're unsure where they are is Table World. So you can hit second graph, and you can scroll around your table looking for these zeros in the y position. Okay? I want to show you something called table setup. You guys interested in learning about table setup? How to make your table go up by 0.1 or 0.5. It's second window. It's called the table setup menu. You can tell your table where to start and how much you want it to go up each time. So I was looking at my graph and I was like, ooh, I think there might be an intercept at 1.5. Maybe I could have my table start at 0 and go up by 0.5s. Now go back into your table. Oh, look at that. See it 1.5? There's another 0. So that's how you can play around with your table setup to look for maybe more zeros that are just not integers. Now, are all 3 of these on our list? Gotta go. All right. -1's on our list right here. +3's on our list right here. And 1.5 is on our list because that's the same thing as 3/2. Okay? You okay on your table setup? I thought somebody said wait. You're good? Okay. So we need to verify now. You can't just be like, these are my answers, I am done. You have to use mathematics and some of our Algebra 2 methods we've learned recently to verify. Synthetic division is your best way to start your verification. Which one do you guys want to verify first? +3. I heard most people say 3. Doesn't really matter. So we'll start with our 3. Do we need any zeros in our setup? We do, between the -7 and the 9, because there's no x value. There's an x to the 3rd, there's an x squared, there's no x to the 1st. Does that make sense? All right, cross your fingers, we get a remainder of 0, because that means 3 was indeed an answer. So we're going to drop your 2. 2 times 3 is 6, add straight down. -1 times 3 is -3, add straight down. And -3 times -3 is -9. Add straight down. Now, you guys want to get wild and do a second round of synthetic division? No. Really? You would rather just factor this? Yeah. Okay. It's not going to be. It's easier to do synthetic. Okay, then let's go ahead and just say, all right, we verified 3 is an answer, and finish off by factoring this trinomial. So the trinomial would be 2x squared minus 1x minus 3. How do you factor a trinomial that looks like that? Box method. Yep. So box method. Put your 2x squared in the upper left box. Put your -3 in the lower right box. Multiply them together to get -6. And now we got to brainstorm. What numbers multiplied to -6 that add up to -1? 3 and 2, I agree. So we'll make the 3 negative and the 2 positive so they add correctly. We're definitely going to pull a negative out of this column over here. How about -3? Probably want to pull a 2x out here. And then I reverse my Punnett square around x plus 1 and 2x minus 3. And I always just check, does every square in my Punnett square work? Make sure I pulled everything out correctly. It does. So my factored form is 2x minus 3 and x plus 1. And that kind of verifies our final 2 solutions are -1. You scroll a little bit. And do you remember how to solve things that look like this? It's the opposite of this number over this number. So +3 over 2. And if you can't do it in your head, you would set it equal to 0 and solve it out that way. So they take a while. You want me to click this and show you everything we did? Wow. We're like scholarly, huh? It's a lot. It is a lot. We would only give you one of these on a quiz. We have to do that whole process. Move it. All right. Yeah, on the quiz we'd only give you one. That would make you do the whole process. It takes a while. It's long. You want to do one more and call it a day? Let's do this one. What degree is this polynomial? 4. So there's 4 answers. Ooh. Yes. So we'll probably do 2 rounds of synthetic division. We could get even more wild and do 3 rounds of synthetic division. Yeah, we probably will, because I'm going to show you how it actually is easier. It's actually easier than box method, Lauren, I promise you. It is, I promise you. I'm so glad to hear you guys like box method. Okay. So our P list is going to be huge because it's all of our factors of 30. Who wants to list them all out? So many. 20 is not on our list.
Isn't it 1 and 30?
1 and 30. 2 times 15. 3 times 10. 5 times 6. I think that's a list, a complete list. My 5 looks funny, but it's okay. All right, what's my Q list? 1 and 2. So just a reminder, your Q list is coming from this leading coefficient. The P list is coming from your constant term. This is going to be a late P list, yeah. It's okay. Put your positive and negative sign in front of everything. Oh, and do we want any double entries? Like if we already have 1 on our list, we do not want to put 2 over 2 on our list, okay? Because that happens, miss, a lot. Positive or negative 1 over 1. Positive or negative 1 over 2. Positive and negative 2 over 1. Aha! 2 over 2? Already on our list, because 2 over 2 equals 1. Positive or negative 3 over 1. Positive or negative 3 over 2. Positive or negative 5 over 1. Positive or negative 5 over 2. Huh, tired yet? Positive or negative 6 over 1. Positive negative 6 over 2. Already on our list. 6 divided by 2 equals 3. Already on our list. Positive or negative 10 over 1. Positive or negative 10 over 2. Already on our list. Positive or negative 15 over 1. Positive or negative 15 over 2. Positive or negative 30 over 1. And 30 divided by 2 is already on our list because it equals 15. Whew. Takes forever. That's beautiful. All right, now what? To the graph. It's appropriate. It's like, you know how Batman goes to the Batcave. To the graph. Because we're math superheroes. To the graph. Mom, how about that? Two. I'm so hungry. 4. Alright, so there's my graph. Again, if you don't find all 4, no big deal. You can use your synthetic. Even if you get 1 or 2, you can kind of get on your way with things. We're looking for all the X-intercepts. 1, 2, 3, 4. There's all 4 of them. Now these ones are probably maybe a few touching a decimal place. That's okay. Just make me get me 2 that are at integer locations. That'll get us on our path. So give me 2 that you can see that are at integer locations. Look on the table. -2 and 0? Well, -2 is at 0. Who else is at 0? 1? Okay. Then I heard 3. And there'll be 1 more, but it's probably the decimal. We'll find it through our process. Which one do you want to check first? 1? Easy enough. Do we need a 0 in our setup? Where?
Yes.
Where? Yeah. There's between the cubic term and the linear term, we're missing the x squared term, so that's the 0. Paige is trying to be a math scholar.
I'm trying my best.
All right, go ahead and do the synthetic. Do it all by yourself. See how you do. What are we looking for a remainder?
0.
Yep. 0. Don't forget to drop your 2. That's a mistake I see a lot. Drop your 2 to start. Yeah, it works. There's my 0. Yay. Now, I know you guys hate doing a second round of synthetic division, but we have to, because if we would turn this into polynomial, it'd be a cubic. You can't factor a cubic. Use a different color. You guys do your synthetic division on these 4 terms. So we already verified 1 as a solution. Who do you want to verify now?
3.
Okay.
What happens if it doesn't equal 0?
Well, then the one you're trying to check is not actually a solution. And then you cry and you use your big, huge eraser to start over. No, you don't have to necessarily start over, but just erase this and try a different one. So this one should work. All right, just because I know you guys hate it and you're not open to this idea at all, I am going to show you how to do a 3rd round synthetic division. So if I would go for round 3 of synthetic division right now, who am I checking?
-2.
So -2. Here goes nothing. So I drop my 2, get -4, get -5, get 10. What would I be left with? We've never done synthetic division down to only 2 terms. But we did verify -2 works. That's my third answer. Do you know how I would take these terms and write it as a polynomial? You'd write 2x minus 5. And if that's the only binomial that you have left, you would just set it equal to 0 to solve it. So what could I do to solve this? Add 5 to the other side, and then divide by 2. So look in your table, look at 2.5 and see if that last answer is at 2.5.
How much is the decimal?
Oh, we haven't done that yet? I thought we
I
did.
think you did, I just was.
Oh, okay. So here is how you get your table to see decimals. You go second window into table setup. You can have it start wherever you want, but you need to have it going up by 0.5s. So I'm checking that 2.5 as an answer because I just got the 2.5 as one of my answers. Look at that. I personally would much rather do one more round of synthetic than have to factor the box method.
Yeah.
But hey, you guys seem to like the box method, so stick with what you know, I don't know. Yeah, I'll click that. You can see the whole entire thing. I'll go ahead and list out all 4 answers because that was our goal. -2 was the answer. 1 was the answer. 3 was the answer. All verified by synthetic division. And then 5/2 was the answer I got at the very end. So we're done. You can, you already have the homework if you already have this paper. It's the bottom part, 11 through 16. All right? For the rest of the time, no, we're fine.
I don't know.